Hello and welcome to this session. So in this session we're going to be talking about Ethernet switching, and this is basically how we transfer messages of layer 2 networks, and these are switch networks. Now if you're into this kind of content, remember to hit the like button, comment down below on this video, and subscribe to my channel so that you're updated each time I upload a new video. So let's get into Ethernet switching. Now, a quick question. Imagine you're in a wired network. What actually makes that physical connection to the network that you are in? And the answer would be the network interface card. This is the component that attaches us or makes that physical connection to a network. And out of this network interface card, we have network ports, and each network port corresponds to a network interface card, and this network interface card is uniquely identified by a media access control address, that is a MAC address. We talked about MAC addresses in the address resolution protocol video, so if you haven't watched that, go and watch that. Now, a switch or a computer forwards data through these network interface cards, and it basically translates bit streams into frames and vice versa, okay, depending on where the traffic is going, whether it's coming in or going out. And when you're talking about switching, we are referring to the forwarding of frames in the layer 2 of the OSI network model, that is the data link layer. Now let us look at basic layer 2 functions. Now when you're talking about layer 2, a layer 2 device can accept a frame from the network. It can encapsulate the frame. This means extracting layer 2 information from segments to get a frame. It can re-encapsulate. That word is hard. It can re-encapsulate. This means embedding bits with the layer 2 info to get a frame, and it can forward the new frame. Okay, let us now look at Ethernet networks. And when I'm talking about Ethernet networks, I'm talking about networks that are in the same collision domain. Now, a collision domain is a set of nodes connected to the same shared medium. Okay, so imagine you have multiple computers on a single network, or let's talk of a subnet to make it way easier. Let us get to understand how packets can be sent over these Ethernet networks. Now, Ethernet networks is a broadcast network built based on the carrier sense multiple access with collision avoidance or collision detection. This means that two frames cannot be sent at the same time, or two packets cannot be sent at the same time in the same network, okay, or on the same wire, since they have a shared medium. Now, a switch separates these collision domains, and this is to ensure simultaneous transmission. And I believe now that we have gotten to understand what we are really talking about. Let us look at this collision avoidance and collision detection techniques that we use when we are on Ethernet networks or layer 2 networks. And we're going to start with the carrier sense multiple access with the collision detection. And this is a technology developed not only to help avoid collisions, but also to respond correctly if a collision does happen. Now, this was used in early Ethernet networks that were half duplex, and they utilized the coaxial cables and earlier versions of the twisted pair cables. And these coaxial cables and the earlier versions of twisted pair cables were half duplex. This means data communicates in both directions, but not at the same time. And what this carrier sense multiple access with collision detection does, it works by checking each computer by checking if each computer on the wire is idle. If the computers on the wire or on the shared medium are idle, then it sends the data. If two computers were to send data at the same time, a collision would happen, and this would lead to loss of data or a distortion of data. Now, this was an early technology, and networks today are full duplex. That means data can occur in both directions at the same time. But what makes sure that there is no collision of packets is the carrier sense multiple access with collision avoidance, and this is used on wireless networks mostly, and it does its best to avoid collisions. Remember, we are in a full duplex, so we are sending data in both directions at the same time. So how do we make sure that packets do not collide? So if a computer wants to send data, it will first sense if there are any other transmissions happening, and if it detects any other transmissions, it will wait a short time before checking the channel again. Now, when it checks again, if no transmissions occur in the channel, it will wait a random short amount of time, then it will send its data. Okay, so it does its best to avoid the collisions, and once the destination receives its data, it will respond back with an acknowledgement saying that I have received the data. If the sending device does not receive an acknowledgement from the destination, it will assume that the computer that was to receive this data did not get that data at all, and it will start sending the packet all over again. Now, there is a protocol that is used when collision avoidance is being in practice, and this is the RTS protocol, which means ready to send protocol. Okay, and what it basically does, it sends a ready to send signal, which requests a send signal to the destination machine, and if granted the request, all other communications happening in the wire will be temporarily stopped, and a clear to send signal will be sent to the sending computer by the receiving computer, and they will start now transferring the data. So carrier sense multiple access with the collision avoidance does its best to avoid collisions, and this is used in today's networks. Now, since we have looked at a network interface card, we have looked at how at basic layer 2 functions. We have talked about Ethernet networks, and let us now see how switch works, or the working principle of a switch. Now, after receiving a frame, the switch learns the source MAC address of the frame, and searches for the destination of the MAC address in its MAC address triple, assuming that the switch already learned the destination of this packet or frame. If the record does not exist in the MAC address table, then it will forward the frame out of all ports except the one that came in through, and after the corresponding device response, the switch will learn its MAC address and store it in the MAC address table. Let us look at the characteristics of a MAC address. A MAC address is unique. It cannot be changed. It is assigned by the IEE based on the manufacturer, and the IEE stands for IEEE stands for the Institute of Electrical and Electronics Engineering, and the MAC address is 48 bits in length. Now, let us look at the frame processing behavior of a switch. A switch processing is a frame entering an interface of a transmission media in three ways. It can either flood, as we have just talked, if it doesn't know where the destination is, or the destination of the packet is. it can forward the frame. It can forward the packet or the frame if it knows the destination of where the frame is supposed to go, and the record is in the MAC address table. So what it will just do is address resolution, and it will just forward the packet, and it can discard the frame if it is not meant for that network. Okay, if none of the devices respond, then it's just going to drop that frame and assume that it's not supposed to be in that network. Now, there are different switching speeds and forwarding methods, and this depend on the how much we look at the frame when it's transmitted over the network. And there are two basic speeds and forwarding methods. And the first one is store and forwarding switching. This is whereby the switch receives the entire frame and checks if it's valid. So it goes through the information of the entire frame, the source MAC address, the destination MAC address, all the details that are included in the frame are checked. Now, in cut-through switching, we don't go through all this information about the frame. We just look for firmware updates. This could be security updates or other updates that are required for the device to continue working properly and securely, and this takes a shorter time compared to store and forwarding switching. Now, that's it when it comes to Ethernet switching. Thank you for watching this one. See you in the IP routing video.